Okay, so here is the balanced equation that we're going to need. Um, Learning to balance formulas. Okay, we did that 2 units ago. And balancing equations, what we did in the last unit. And now we're applying all this stuff to this new thing called stoichiometry. Now that we have this, we need to teach you about Avogadro. Well, the video talked about Avogadro, right? Yes? Okay. Here's what's important about that. There are 6.02 times 10 to the 23rd power particles of anything in 1 mole of that anything. Yeah, 2, 2, 1, 2, doesn't matter that much because I'm fine with this number here. Okay. So our equation shows 2 formula units. Of KOH, 1 of CaCl2, 1 of calcium hydroxide, and 2 of KCl. Okay? If we multiply all those by 6.02 times 10 to the 23rd, we're going to have a bunch of big numbers up there, right? Yes? But they're not really that big because we could say that, well, let's say we will have one mole. I'm sorry, that'd be 2 moles of KOH. 1 mole of calcium chloride. 1 mole of calcium hydroxide. And 2 moles, boy, I'm having trouble with that today, 2 moles of KCl. Does everybody agree with that? Do you understand what we're doing? You guess? Really? Well, if 6.02 times 10 to the 23rd particles of anything equals a mole of that thing, then if I multiply this 1 calcium chloride formula unit by 6.02 times 10 to the 23rd, I have 6.02 times 10 to the 23rd formula units of this, but it's a whole lot easier to write that as 1 mole, right? Does that make sense? Anybody lost? Please have the courage to speak up and say so. Okay. The reason we want to do that will become apparent as we move along in this unit, okay? The mole makes the math easier. The mole makes the math easier, okay? The mole makes the math of stoichiometry easier because the mole is equal to so many things. The mole makes the math of stoichiometry easier because the mole is equal to so many things. We've just shown you one here. It's equal to this number, okay? And that number is called Avogadro's number, Okay? You need to remember Avogadro's number. Okay? Avogadro? Now, we'll keep up with it. We'll remember that you got to memorize Avogadro's number. You never know when you're going to have to call him. Slow on the uptake, are you? Okay. Here we go. What? There you go. You might need him in emergency. There you go. All right, here we go. So, if we have 12 moles of KOH, hey, kind of sounds like this down here, doesn't it? Starting with our problem up here, we had 12 moles of KOH. A bunch of moles down here. Okay? Here's what we can do. We take our starting amount. Oh, from Unit 1. We'll go back to Unit 1. What did we do with starting amounts in Unit 1? No, we didn't measure starting amounts. That was in the lab. We're talking about it. We're doing math with it, okay? Unit 1. Put it over something. 1. Always put your starting amounts over 1. Now, there are times when you don't, but in here, I don't think it's ever going to come up that we don't put starting amounts over 1, okay? What? So we're converting, and this is what we learned to do in Unit 1. We learned to make conversion units. Now, this is not going to be a conversion unit because the fraction is not going to equal 1, but it's going to be a molar ratio. That's what we need to convert from one species to another, a molar ratio. Yes? Yeah, and can you wait just a second? Okay. All right. So if I have moles on the top here, think back to Unit 1. I need moles on the bottom. Moles of what? KOH. There you go. Okay, and how many moles of KOH do I have in the balanced equation? Yes, 2 moles right there. That number right there, that coefficient, which up to now meant 2 formula units. But now we're going to say it's equal to 2 moles because we're multiplying all the formula units by Avogadro's number. You with me? Shake the cobwebs out of your head. All right, here we go. So we have 2 moles of that. And what do we want to convert to in the problem? No? Moles of calcium hydroxide. Where's calcium hydroxide? Right there. How many moles of calcium hydroxide in the balanced equation? 1. That's what we're going to put on the top. Do the math. What? 24? Yeah, I know. Don't do that in here. Don't do cross multiply and divide, please. All right. Well, I left out one thing. One more thing we got to do. I taught you in Unit 1. One more thing I failed to do before I did the math. Yes. Booyah. Okay. How we doing? Does that look hard? Shouldn't be. We'll get to all that. We'll get to all that.
That's what I was confused about on my school. I was trying to use the common math, and I was like, where am I doing?
Yeah, I know. KISS. Okay. All right. Let's let you try one now, okay? That's it. All we had to do was convert from one thing to moles of something else. That was the answer.
What is that number?
What number? Avogadro's number? We multiplied all the formula units by Avogadro's number to do that.
How?
We just did. We said right here that this many particles of anything equals a mole of anything, right? That's Avogadro's number. So what we did down here was we multiplied all those numbers, all those coefficients mentioned right here, 2, 1, 1, 2, by Avogadro's number, and in doing so, we got a mole of KLH, a mole of calcium chloride, a mole of calcium hydroxide, and 2 moles of calcium chloride. Potassium chloride. That's how we got moles. We multiplied them by Avogadro's number. What? You want to do that? You want to multiply all those by Avogadro's number?
Yeah, let's do it.
Really?
But, I mean, then just get,
Since one
You get the
KLH
same
per
number.
mole.
Example. All right, I'll just do the one of them, okay? I'll do KLH. Got it?
uh-huh.
All right, I've got 2 moles. I've got 2 formula units of KLH, which I'm going to multiply by 6.02 times 10 to the 23rd power. Okay? And since it applies to any particles, okay, this can be formula units. Okay? How many formula units of KOH am I going to have? 2.
You have 2 right now.
Right, but how many formula units am I going to have when I do this multiplication?
A lot.
12.04 times 10 to the 23rd. Is that right? All right, 12.04 times 10 to the 23rd power formula units.
So we started off with 12.9.
But is there a simpler way to say that?
Just say mole.
Equals 2 moles of KOH. Now, which one do you want? This one or this one?
If you're just going to say 2 formulas, we won't equal 2 moles.
Well, they don't equal 2 moles, but if I multiply all the coefficients by Avogadro's number, then I can say this is 2 moles, 1 mole, 1 mole, 2 moles.
Okay.
Got it?
Yeah, I do.
Okay, just want to make sure. All right. It's really important to understand the concept. The math is really pretty simple, but it's important to understand the concept. All right, here's your next practice problem for you to do, okay? Okay, if 5.00 moles of ethane is burned, how many moles of oxygen will be needed? That's your next practice problem.